Hey everyone, and welcome back to our Python data analytics series. In this episode, we're going to go over data visualization in Python, which essentially means plotting graphs in order to see what our data actually looks like. Sometimes just by looking at a dataset table, we're able to draw conclusions on simple things. Like for example, in our dataset, it may say, okay, it looks like the United States has the highest average overall scores through all these scores here, and then obviously the highest total score. Or hey, maybe we look at Canada and say, I'm going to guess that Canada maybe has higher average scores than Israel does. The question then becomes, how can we actually look at our data in a way that makes sense and makes these conclusions easier to come to? That's where data visualization comes in. So data visualization is basically just the graphical representation of data in a way that makes it easy for you to understand and easy for you to communicate to others without them needing to have any sort of knowledge of the dataset. Probably the most common library you're going to see in Python for data visualization is called Matplotlib, which just stands for Material Plotting Library. You can find all their documentation on matplotlib.org, which is actually the website I'm on right now, and I'll go ahead and leave that link in the description of this video. They have tons and tons of examples of different types of graphs you can make, and you can click on basically any of these graphs here and get access to the source code for them to implement yourself. In this video, we'll go over a few of the more basic ones to help you get an understanding of how it works. So like Pandas and any other external library, we want to first import the library into our code. So to import Matplotlib into Python, all we need to do at the top of our code is just type this line here. So it'll be import matplotlib.pyplot, and then almost everyone uses the same abbreviation for the import, which is just PLT. So we'll just say as PLT. Then, similar to how we use pandas as PD, anytime now when we use the Matplotlib library, we can just use this PLT as our reference object. So first, let's actually just mess around with some plotting using our own data and not from data from the dataset, just to give you kind of an idea of how the plotting works. The first graph we'll make will be a super simple linear function using a basic x and y plotting scheme. So to do this, I'm just going to make two variables, an x variable and a y variable, that will each represent their respective axis. So for the x variable, let's just make something, we'll say x equals list in range, or all numbers in range 0 to 10. And then we're going to make y equals list in range 10 to 20. So basically all we're doing with these is just making a list with all the numbers between 0 and 10 for x, and then making a list with all numbers between 10 through 20 for y. And then to access the most basic x and y plotting function in Matplotlib, all we need to do is just type something like plt.plot, and then we're going to pass in x and y in that order, because the first argument will always be interpreted as the x-axis argument, and the second argument will always be interpreted as the y-axis argument. So then, if we go ahead and run this code chunk, you'll see that it now prints off a very simple linear function on this graph. There are quite a few different customization techniques for a simple line graph. One such example would be changing the color of the line. So in this plot function, we can actually add a third argument. We can add a color argument like this, and then we can set it equal to any well-known color we want. Let's say we want red, so I'm just going to type in red as a string like this, and then if I were to just run it again, you would see it now changes the line to a red line. So it's kind of different, a lot of customization things like this that you can kind of use, and they'll all be separate arguments you can actually just pass into these functions. If you want to see a whole list of the different customization options you have, you can go to the Matplotlib website and check out this function here, this plotting graph, and it'll give you a whole list of things you actually could pass in. So all the documentation is there, and that's where you can look at it. One other important customization thing that I should mention is labels for both the x and y axis. This is a super helpful thing to know. So to label the x and y axis, all we need to do is make a new line, and we'll make plt.xlabel, and then we can make it equal to any string we want, and I'll say plt.ylabel as well. For the x label, just because this data doesn't really mean anything yet, I'm just going to say like insert x label here, and then for the y one, I'll say insert y label here. And then one last thing, by default, the graph will be displayed if any edits like this are made to it. However, if we want to explicitly display it, we can just at the bottom here, just type plt.show like this. Then if we run this, you'll see that it now has labels added plus the color, and it shows the entire graph. So we see insert y label here on the y-axis and insert x label here on the x-axis. Next, let's look at a scatter plot. So scatter plots are going to be plotted in pretty much the exact same way a linear plot would, except that we would just call a different function to graph it. So I'm actually going to take all of this code here, I'm going to copy it, and I'm going to paste it into this. And then I just want to change these x and y variables around a little bit. So I'm going to make x just a list. I'm just going to pass in some random numbers. I'll just say, let's make this up as I go. I'll say 1, 3, 6, 8, and 14. And then I'll make y also a random list of things. I'll say 4, 7, 7, 10, and 12, just like that. And then all we need to do to make it a scatter plot instead of a regular linear plot is just to change this function here. Instead of dot plot, we're just going to type dot scatter. And then if I go ahead and run it now, you'll see that we have 5 dots for each corresponding coordinate. And it does the same thing that the linear plot does, where it sets coordinates depending on the value. So for example, 1, 4 is the first coordinate, 3, 7 is the second coordinate, and so forth. What's really interesting actually about this graph is that if we switch the graph to just plt.plot instead of plt.scatter, and we run it, notice it's actually the exact same thing. However, with the linear plot, we're basically just playing connect the dots with all the points, whereas with a scatter plot, we're just showing the actual points themselves like this, if that makes sense. So this is how you do a scatter plot, pretty much the same as a linear plot, just writing scatter instead. And scatter plots are actually something we're going to look at a lot in future videos because they're very, very useful for something that we call correlation, which we'll look at starting in the next episode. Now, the next type of graph I want to go over using this library is a bar graph. So bar graphs are a simple method of data visualization that give the total count of a series of variables. Let's actually go down to this new code chunk down here, and I want to go ahead and just make my own list to give you an idea of how bar graphs can work. For bar graphs, we need two primary arguments, the labels and the actual values themselves. So let's make a variable for each one of those. I'm going to make a variable. I'm just going to call it labels. I want to make it a list. I'm just going to pass in like A, B, C, and D for right now. And then for our actual values, let's make another list called values. I'm going to set it equal to, let's say, 10, 20, 30, and 40. And then to actually plot this graph, we can just go down here, and we can just type plt.bar. And then what we're going to do is pass in our labels first, and then our values second. And then just like last time, we can write plt.show at the bottom of this block to explicitly have the code show us the graph. So we want to make sure when we're doing a bar graph that we're always passing in the labels argument first, because it has to be in that order. The labels have to be the first one, and then the values have to be the second argument. So now if we go ahead and just run this code, you'll see it now prints out a super basic bar graph that has 4 points of data. And notice how the ordering of the labels and values actually matters, because the order determines what gets assigned to what. So for example, the first label here is A, so A gets assigned to 10. B is the second one here, gets assigned to 20, C gets assigned to 30, D gets assigned to 40, and so forth. And this becomes important when working with actual data sets because we want to make sure our data has the correct labeling. And then in the same way we did this with our previous graphs, we can change the axis labels. So let's just add in some lines here. I'll say plt.xlabel, and then I'll just pass in, I'll say label axis. And then I'll do plt.ylabel, and I'll just have this as the value axis. And then we can actually add a title to our graph as well. I'm going to make something down here. I'm going to call it plt.title, and then we're just going to pass in, let's just say, graph title like this. And then now if we actually run this, you'll see it now has a title just called graph title, then the value axis, and then the label axis. And also, just like the previous graphs, we can add some customization things to the graph if we want. So let's add some colors here. Let's just add a new list here. I'm going to call it colors, and then let's just make a list of just some well-known colors. Let's say red for one, then we'll have green, blue, and then let's just say purple. Now, we can then pass in this list to the actual bar function to get it to plot the colors. So to do that, all we need to do next to here is make a comma for a third argument and write color equals, and then we're setting equal to this list we made here, which is just colors. So we're just saying color equals colors. And then if we run this code chunk here, you'll see it now makes our graph colored based on the color list we made, and also in the exact same order we pass it in. So the first one is red, second one is green, third one is blue, fourth one is purple. Another super quick customization thing we could do to change this bar function would be to change it to bar H instead of just bar, which just means horizontal bar function. So if I just change this to bar H instead of bar like this, and I run it, it just flips the axes to make the bar graph horizontal as opposed to vertical. Now the only thing that if we were to do this, we should note is that we need to swap our labels around, because now you can see that on the y-axis we have value axis, on the x-axis we have label axis, where actually it should be the other way around to match it. So if we're going to switch it to horizontal, we got to flip our axes as well. So let's change this to y label and then x label. Then if we run it like this, you'll see it now has the correct axes labels. Okay, so one more graph I want to go over before we get into our actual data graphing is the idea of a histogram. So histograms are a super common type of graph that are used to show the numerical distribution of data points over given intervals. That may sound kind of complicated, but it's actually very useful as a graph and not very hard to actually implement. So for our model data, let's just create a bunch of random data points. To do this, I'm going to use the NumPy library, which is a super helpful library that is used in all sorts of computing and Python, and adds tons of helpful functions that we'll go over more in future videos. For now, though, let's actually just import that library in this block. So I'm going to say import NumPy as np, and this is how I'll access this library. So I'll just go ahead and just run this real quick, just so we have it. So I'm going to try and just generate a random set of numbers here. So let's make a new variable. I'm going to call it data point and set it equal to np, which is just NumPy that we just imported, dot random, dot normal. And then I'm going to pass the numbers in, and I'll explain exactly what they mean here. So what this basically does here And this just generates a normal distribution of data points where the first number is the number it's centered around, so they're all going to be around 100. The second number is the standard deviation, and the third number is the amount of data points we're actually generating. So if we now print this out, let's just print data points, and we run it, you can see that we've now actually printed 100 data points that are all somewhat in the ballpark of 100. So now let's use these to actually show you what a histogram looks like. So I'm going to go ahead and delete this print here, and then I'm going to make a histogram. To do that, all we need to do is type plt.hist, and then we're going to pass in the data points that we have. If you're starting to pick up on the pattern, you can tell that whenever we're using material plotting library or PLT, to do a type of graph, you generally just are going to type the abbreviation of the graph name. So like histogram is just hist, bar is just bar, obviously, and then you have like scatterplot is just scatter, and so forth. So that's kind of the general pattern that it follows. So let's go to the bottom, let's type plt.show like this, and then if we run it, you can see that it's now printed off a histogram here. So basically, how you read a histogram is you look at the bottom axis to find the ranges, and then the blue bars determine the frequency of entries in each range. So for example, it looks like our ranges are in increments of 5 if you just look at the width of the blue bars. So this first one on the very left around 70, looks like it goes from about 70 to 75. And then we look at like the one from 80, goes to 80, 85, and then 85 to 90, and somewhere in that range. So basically for each range, you can look at the height of the bar to see how many data points fall within that range. So just to kind of give you an example, if you look at this first one here with like that's around 70 to 75, looks like there's probably, it's probably too tall, according to the y-axis, so it's probably 2 entries in that range. If you look at the 80 to 85 one, I'd say maybe 7 or 8. 85 to 90 would be right around 5, and so forth. A normal distribution is one that follows somewhat in this shape, basically where it tapers off kind of at each end, and then has many entries located right near the middle. Hence why we use the normal function up here like this, because that makes a normal distribution. So I could sit here all day and demonstrate all different types of graphs with material plotting library, but there's so many different types that it would actually just take forever. However, once you get familiar with plotting one or a few, the rest will actually follow pretty easily, as the process is pretty much identical in all of them. It's just the fact of you're calling a different name on each one. So make sure you have your data points or labels ready, and then you just find which material plotting library function you want to use, call the function on your PLT object, and then pass in the data points or labels. So now that we have a solid understanding of how to make some basic bar graphs in material plotting library using just fake data that we made, let's actually implement the data from the dataset we've been working with in our AI Global Index. Let's now implement what we learned with a basic line graph to model some data from our dataset. One thing that line graphs are effective at is seeing the correlation between two variables. So for example, if we go ahead and scroll up here and look at our actual dataset, what if we look at this dataset and we looked at the total score variable here, and then we were wondering which of these variables is basically the best predictor of the total score variable. If we wanted to know this, we could just put total score as our dependent variable, and then just try out multiple of these variables like talent or infrastructure or operating environment as our independent variables. And then if any of the graphs look somewhat like a one-to-one line or like a y equals x line, we could possibly conclude that there is a strong correlation. So that would mean a line that looks something like this, where it kind of goes straight up diagonally, meaning they're positively correlated. So let's do just that. So let's go actually down to this code block down here, and I'm going to make an x variable and a y variable that is equal to x-axis, just like we did with the model data. So to set these variables, we can use what we learned about data selection in our selection episode. So let's first set our y variable, which will be our dependent variable, to total score. So to do that, let's just write dataset, and then we're going to select total score like this. And then for this graph, we wanted to cycle through some of our variables for our x variable to see if there's any apparent correlation between any of them. In our dataset, every one of the variables like talent, research, operating environment, etc., culminates to make the total score, so there will likely be some degree of correlation in all of them. But we can look and see which one has the strongest degree of correlation. So just to start off, let's just select, for instance, let's say the talent variable. So let's make our x variable equal to dataset, and then we'll select talent. And then we'll use what we learned with graph creation to just basically plot this with PLT. So we'll say plt.plot, and then x and y. And then real quick, I want to make axis labels before we print it out. So I'm going to say plt y label is total score. And then we could say like plt x label is equal to, let's see, talents. And then we'll just say plt.title is total score versus talents. I'll separate that a little bit to make it look a little cleaner. And then I'll write plt.show at the very bottom. And then if we run this graph, oh, oops, I mistyped that. It should be plot, not plt. So then if we run this, the graph will look something like this. So we have our x-axis, which is our talent column, and our y-axis, which is our total score column. Because there's not many data points in this data set, the line is looking rather jagged, but does appear to be positively correlated to some degree, meaning that as our independent variable talent increases, the dependent variable total score tends to increase as well. Looks like there are definitely a few exceptions, particularly the jagged point right around 20 for talent and 60 for total score, but it is generally trending positively upwards. So next, let's take a look at another variable for our x variable. And actually, just to make a quick upgrade to this, instead of having to change all the labels and stuff, we can actually just do something like this. I'm going to say xvar equals like talent, and then instead of having to retype it, I can just pass it in this variable here. So I'll say like xvar like this, and then I will say xvar like this. And then let's just pass that into the title as well. I think this should work. Let me try this real quick. I'll type in xvar like this. Let's see if it gives me okay, it might get mad that I'm doing that. Let me try it this way instead. Xvar like that. Okay, there we go. So yeah, that works. I'll go ahead and space this out. Basically, the idea of what we did there is just if we want to change the x variable to look at different variables, we don't have to actually change it in every single field. So now if we wanted to change it to something like, let's say, infrastructure, we could run it like that, and it would change the actual variable itself, plus the axis label, plus the title label. Once it's run, you can actually see that this line graph seems to be pretty jagged as well, and possibly a little bit less correlated with total score than talent was. There's definitely still a positive trend in the upwards direction, however, it's much more jagged in the middle and has a few more outliers. Let's look at another one, say operating environments. Let's change the x variable here to just equal, we'll say operating environment. I think it's lowercase like that. Run it here. Okay, maybe it's not lowercase. Environment. There we go. So it looks like this graph is probably even worse than the last one. It's really jagged, meaning there's a lot of deviation. There's still obviously a trend upwards. However, it's weaker than the previous two, and operating environment doesn't really seem to be as heavily correlated to the total score. Let's look at one last variable. Let's look at research. So I'm going to change this to research instead. And then I'm going to go ahead and run it. And voila, this graph actually looks a lot better than our previous graphs and probably the best one yet. As you can see from this graph, it looks almost perfectly diagonal, minus the obviously there's a few jagged edges towards the beginning, which says to us that generally, as research increases, total score tends to increase as well. In the same vein, as research decreases, total score tends to decrease as well. We could do this for a while for each variable, but you basically should get the gist of it now. If you want to use a line graph, you typically select two columns from within a dataset and plug them into a material plotting library, and the resulting graph can tell you a lot about the correlation between two variables of data. What if, however, we don't like how this linear plot really looks? Frankly, the line being super jagged looks kind of ugly, and it's definitely not the cleanest way we could show correlation. When we have a bunch of point like this, it's going to be better to use scatter plots instead of line plots so we don't have all these jagged lines. So all I'm going to do is actually just copy and paste, or actually copy all this thing here. I'm going to go into this code chunk here where we have the scatter plot. I'm going to paste it all in like this. And instead of having plt.plot, all I'm going to do is just change this to plt.scatter. And then now if I run this, you can see it actually looks a lot better. Now we just have the values themselves instead of having a million different little lines connecting them and making the graph look a little polluted and dirty. Again, we could easily change this x variable to something like operating environment. So I could do operating environment and then run it. And it would look something like this. This is not very correlated. It looks like it's kind of ugly. And then I can go, just change it again. Look at infrastructure this time. I'll go infrastructure, a little better. Let's do what we did last time. I'll go talent again. Basically, all I'm doing is the same thing as the line graph. I'm just swapping out different x variables. And again, I'm just using a variable here that I can just change once so I can plug it into the x label itself, plus anytime I'm actually like labeling it on the actual axis or the title. And again, scatter plots like this are actually super helpful for looking at correlation, much better than line graphs in my opinion. And we're actually going to be using them a lot in our future episodes. So make sure you just know how to do a simple scatter plot, but it's pretty easy. All you need to do is have a x column and a y column, and then call plt.scatter, and then pass in x and y as the two arguments. Next, let's move on to using bar graphs with real data. So let's actually go back up to our data here, and let's think about how we could use a bar graph for our data. It wouldn't really make much sense to do like a frequency counting kind of thing with our numerical data, because that's what histograms are good for. Instead, we could just find the total frequency for each possible answer in one of our categorical variables, like region, cluster, income group, or political regime, and then plot it using a couple of bars. So actually, for instance, let's take the column income group, for instance, and within income group, we'll find the total count of each answer. So basically how many countries are in each income group. So to do that, we can actually use a really simple function in Pandas called value counts. So I'm actually going to go back down here, and then I'm going to call a function. I'm going to say, let's say dataset dot value counts, and then we're going to pass in the column we're looking at. And then if I go ahead and just run this line here, you'll see that it prints out the counts of each income group. So there are 43 incomes that are high, 10 that are lower middle, and 9 that are upper middle. So we know from looking at our bar chart earlier that we need to have labels as well as values, and we're going to pass in labels first and the values second. And there's a super simple way to get our labels. So let's make our actual value counts into a variable to basically just capture the output. So I'm just going to name it like income counts and set it equal to what we just made. And then to get our labels, all we need to do is make a variable. Let's just call it labels. And then we're going to set it equal to list income counts.index. So basically what this is whenever we run the value counts function, it returns what's called a series in Pandas. And to access the names, we need to use the index attribute, hence why we're calling income counts.index. And then we're wrapping this all in a list because we want to convert the whole thing to a list so we can plug it into our graph. And then to make our values, it's pretty simple. We'll just say values, and then we're going to do list as well, and then just make it our income counts thing here. If we access the income counts directly, it'll look at the values, and you want to turn that into a list as well. So now let's actually make our graph. So let's go down here. I'm going to type plt.bar, and just like last time, we're going to pass in our labels first and our values second. So I'm going to pass in labels and then values like this, and then I'm going to type in plt.show down here. So then if I go ahead and run this now, you'll see it gives us a nice bar graph that details the frequency of each income group. Of course, this graph corresponds directly to our value counts function. So high has a count of 43, lower has a count, lower middle has a count of 10, and upper middle has a count of 9. So now let's make some helpful labels just to help us look at this graph a little better. Right here, I'll add plt.x label. We'll say income group, and then I'll make plt.y label. I'll just say count, because that's what we're counting. And then I'll make a title. I'll just say plt.title, and then we're going to say counts of each income group. And then if we run this, you'll see we have a very nice example of a simple bar graph that is labeled and counts the frequency of each categorical variable in the income group. And just like with our example bar graph, we can change the colors if we want to make a colors list. So let's actually go down here. Let's make a colors list. Let's just say, make a list here. I'll just say green. Let's do green, red, and blue. Green, red, and blue like that. And then now, forgot to pass it in. Do color equals colors. And then now if I run it, you see that it has nice color variation now. And also like the previous one, we can change this to bar H if we wanted to turn this into a horizontal bar graph. So I could do something like this. And it would change it horizontal. I would just need to make sure to switch the axes around if I did that like this. Next, let's look at implementing a histogram using our actual data. This one will actually be the simplest of all the graphs we've looked at so far. So to make a histogram, all we need to do is grab a single column of numerical data to check the frequency spread on that column. Let's look at perhaps the most valuable numerical column in the whole data set, which is our total score variable. So let's make a variable called values. I'm just going to set it equal to the total score column. So I'm going to say dataset total score like this. And now that we have the column, the only thing we need to do is to make a histogram is to pass in our dataset here, our column here, values, into plt.hist function. So to do that, all we need to do is type plt.hist. I'm just going to pass in values here, and then I will type plt.show. And then now if we run this, you'll see we now have a histogram of our data. We have two outliers kind of here on the right-hand side. We have one near 100 and one near 60, which if we actually look back at our data set, we can see that those are the US and China. However, most of these fall kind of in the 0 to 50 range, which can be seen if we just look at our data set in tabular format. You can see if we just go up here, obviously we don't have all of them printed off, and these are the top ones, but we have the two outliers here, US and China, and then the rest are going to fall, that's development. US and China here, and then the rest are going to fall, kind of 0 to 50 or 0 to 40 in the range below that. So I'll go ahead and just scroll back down here just so we can see it again, and you can see it reflects the table pretty well. So what this histogram basically does is help us better visualize the distribution of all total scores within this index. So similar to all of our other graphs, let's make some helpful axes labels and a helpful title. So I'll just do plt.x label. Let's say this will be total score. Oops, I can't type. And I'll say plt.y label. I'll do frequency. And then we'll have a title. Let's just say frequency of all total scores. And then if we print it off, We have a really nice histogram that gives us the frequency distribution for the total score column, obviously now with labels. If we wanted to change the variable that we're looking at, all we'd have to do is change the column we're selecting. So for example, we could replace total score with research here, like this. And obviously I need to change the labels too, although for now I'll just run it just so you can see. And we get a different histogram entirely. If we run it, you see this histogram is a bit less balanced than our previous one, as it's a lot more right skewed, with most of the entries occurring on the left-hand side of the graph. Hopefully now you should have a solid understanding of how to make line graphs, bar graphs, histograms, and scatter plots in Material Plotting Library. I wish I could go over every single type of graph in this video, but Material Plotting Library has so many graphs that it would take forever to get through all of them. However, now that you have a basic understanding of how graphing and visualization works with Material Plotting Library, you should be able to use their graphs in the future with some moderate adjustments. I'll post the link to Material Plotting Library in the description, and with that, you'll be able to access every single function in the library and see what all different types of graphs they have. If you want to make more advanced visualizations, you can use a library called Seaborn, which is actually based off of Material Plotting Library. For now though, you can take the knowledge you've made with Material Plotting Library to get yourself started on the right track. In the next video, we'll go over some concepts of statistical analysis and really dig into some of the analytical aspects of this course. I'll see you in the next one.